Hello and welcome all to another session of the Rain Enhancement Hub webinar series provided and hosted by the UAE Rain Enhancement Program. My name is Mohammed Mahmoud, and I am Chief Executive Officer at the Climate and Water Initiative, as well as the lead for Middle East Climate and Water Policy at the United Nations University Institute for Water, Environment and Health. Additionally, I am a member and chair of the Strategic Directions Committee with the UAE Rain Enhancement Program. Today's webinar is centered on the recently concluded Weather Modification Association meeting that took place in April 2026 this year in Reno, Nevada. And amongst many of the talks that were part of the proceedings, it did include several recipients and participants and awardees of the UAE Rain Enhancement Awards. And so several of those speakers are joining us today to talk about their projects, to also discuss their work, and then specifically some of their feedback and engagements that happened at the Weather Modification Association meeting, especially as it relates to their work and their projects that they're currently conducting with the support of the UAE Rain Enhancement Program. So I'll be introducing our speakers here, and as we do that, they will come and join us on the webinar stream, and then we're going to dive into the questions associated with their work, as well as the engagements they had at the Weather Modification Association meeting. So I'll start with introducing Dr. Will Cantrell with Michigan Technological University. Dr. Cantrell was a Cycle 5 awardee from the UAE REP program, UAE REP award cycle, and his work and project with the program is related to laboratory and modeling studies of cloud susceptibility to hydroscopic seeding. Second on our panel is Dr. Danny Rosenfeld with Hebrew University of Jerusalem, and he also was a UAE REP Cycle 5 awardee. His work centered on the identification of clouds' microphysical seedability in an actionable manner. And then our final two panelists, Dr. Michael Dixon with EcoScience Works and Dr. Roloff Berger with Northwest University in South Africa. And they were both Cycle 6 awardees with the UAE Rain Enhancement Program, and their project is on advancing cloud seeding science with dual polarization, radar signatures, and AI. So welcome to all of you. Thank you for joining our panel and our discussion. We look forward to hearing from you on both your work as it's ongoing, as well as how your work had an impact, I believe, on the Weather Modification Association meeting about a month or so ago. So let me start off with the very first question to all of you, and I'll call on all of you as you all respond to it. Just very briefly, again, for our audience, maybe not everyone is up to speed in terms of your work and your projects with UAE REP. Very briefly, if you could share sort of a description or a synopsis of the work that you presented at the WMA meeting, just to sort of set the stage for the follow-up discussion we'll have related to that and the meeting. So with that, I'll ask Will to start first, and just, again, a very, very brief sort of description of the work that you presented at the meeting, obviously as part of the larger projects that each of you are conducting.
Thanks, Mohammed. Happy to be a part of this webinar. We had 3 presentations at the conference covering two specific presentations on the laboratory studies that we've been doing, and then another presentation on some modeling, which ties together some of the laboratory studies. In brief, what we're really trying to understand is the response of a liquid water cloud to a hygroscopic powder. So one of the ways that you can think of potentially enhancing precipitation is through introducing large droplets into the cloud. And typically the way that's done is through some kind of microscopic powder, salts, for example. And we're studying how that can be introduced and what effect it would have. So we had two presentations on that, and then another presentation specifically looking at modeling studies, which will give us some insight into things that, despite the fact that we have a very well-controlled laboratory simulation, or sorry, laboratory experiments that we can run, we don't have perfect control. And so there are some things that we can't follow or can't measure in the fidelity that we would like. And the modeling gives us some insight benchmarked against the experiments, which is a really important aspect. The models give us some insight into how that process is working.
Excellent. Thank you. Thank you for that summary, Will. I'll call on next on both Michael and Roloff. I know you're tackling elements of the same project, but I know that both of you were there in similar but maybe different capacities. So I'll ask on both of you respectively to share also your description of the work that you shared at the meeting relevant to UAE REP.
Okay, well, let me just start. Yeah, thanks for giving us this opportunity. It's very nice to have the ability to communicate what we're doing. In Reno, we had two major, what we did. I gave a presentation on basically an overview. Since our project has just started, it's an overview of what we plan to do. And then we also did a one-day workshop on Titan, and trained the participants on the various aspects of Titan in its legacy form. And at some point, and Roelof can cover that in some detail. My talk, so our project and the talk covered, that material is, sort of has two major parts to it. One is on the improvement in the observations, the dual pole observations that we now can make on operational radars for the purpose of, conducting and evaluating weather modification. And a big part of that is data quality is highly improved with dual pole, but also you can start to get a handle on, what are the microphysics, what's happening in a storm. Previously to dual polarization, we were only able to do a sort of geometric aspects of a storm size and so forth. So now we'll be able to get, at least make a start on understanding what's happening in a storm. And then having made those observations, we hope to be able to use AI to do, three things: improve the forecast, what's the storm likely to do, give us some insight into the seedability of a storm, how suitable is it at the time for seeding, and then thirdly, to evaluate the effect of the seeding. So some kind of seeding signature, we hope, to be able to detect some kind of seeding signature, which is more sophisticated than the work that we've done in the past on randomized experiments. And then I'll hand over to Roelof. He can talk about, our Titan workshop.
Excellent, thank you. Roloff, hopefully you can hear me.
Sure.
Excellent.
Yes, coming from a third world country, our research is much more applied, and by definition, what we do should be impacting on society, and for that reason, my work focuses on using these advanced systems and software that Mike spoke about, but using it for early warning systems and for more generic problems. And I want to highlight that because it's one of the important things that the UAE REP program does. It doesn't only support rainfall enhancement, but the problems that we're working on, and what Will and Prof. Danny will also share is problems that has very much applications in other spaces. So the software that Mike was talking about, LROS, is widely used around the world, and also in South Africa, our National Weather Services use it. So this project is a great opportunity for us to strengthen this the application of rainfall enhancement in the LROS package, but also to keep it maintained and working, and using these new AI modules that we're working on to improve nowcasting, and that will help us to do better targeting of cloud seeding projects, but it will also help us to improve early warning for National Weather Services. So I'm really excited to be part of this initiative.
Excellent. And then just maybe I'll pull on specifically Roelof in terms of, just sort of a brief description of your engagement at the WMA meeting.
So I was, along the same note, Mike and I had the privilege of doing the one-day workshop where we had participants from all around the world, and we introduced them to this LROS software. Most of the participants had no previous experience, and we hope to continue these workshops to also take them to the advanced place, and where we ultimately want to end is evaluation. This is also a key theme of the workshop that we were at, and I'm sure of what we're going to discuss today is the need to improve our evaluation of operational and research cloud seeding programs. And what our project hopes to do is to find more physics-based ways of doing that for warm cloud seeding programs. And then, of course, we also participated during the conference in discussions around the use of AI, and that was also very positively received by the community.
Excellent. Thank you. Thank you. Dr. Danny Rosenfeld, just again, a brief description on your on the work that you presented at the WA meeting that was relevant to your UAE REP project.
Well, first, it's a pleasure to be here, and in the framework of the UAE REP. We presented there two virtual presentation and one actually attended presentation on our project. Our project is actually trying to deal with the huge variability in the parameter space of clouds, thermodynamic and microphysical properties, and try to detect the seedability of the clouds by spectral bin microphysics model simulations within this parameter space, where we take situations that are representative to a wide range of situations from the UAE, desert mountains, UAE low cloud base, in other places in Africa, from the very pristine to the very polluted, including the high veld where Roelof is, and simulate the seedability with different seeding methodologies. The simulations can be applied to actual seeding operations and experiments only if we find a way to identify the situations in near real time by the manifestation of these cloud properties in the multi-spectral satellite channels. And presently we have sufficiently accurate satellites, geostationary satellites, the Meteosat third generation, that allows us to do so. So we simulate the satellite channels and apply this and use machine learning to learn the seedability based on this signal. So we presented the overall project in one talk, presented the satellite technology in the second talk, and the machine learning, the way that we can actually get the seedability in the third talk.
Excellent. Thank you. Thank you for that summary. So now I want to shift the conversation to discussion on, having been at the WMA virtually or in person, based on your presentation that you all have, or presentations or engagements that you all have provided, and maybe some of the discussions that have occurred, especially for those of you that were there, or even the Q&A that happened potentially after your virtual presentations. My question really is on what feedback or insights did you find most valuable regarding your project or research that you received as part of that engagement at WMA? Particularly to maybe some of the novel elements of your projects, areas such as the integration of AI to support cloud seeding, the development of new seeding materials, or the efforts to assess and improve cloud seedability. What were some of the sort of interesting feedback or insight you received regarding your project? Whether it could be as simple that it's great, it's adding value, I think we all know that, but maybe any sort of nuanced feedback that you received that was sort of helpful for you in terms of your project and assessing sort of your project's place in this field of cloud seeding and rain enhancement. Danny, I'll go in reverse order this time, so I'll start with you. If you can share any interesting insights regarding your project.
Well, my greatest insight is that there is no replacement to be actually there. Virtual participation doesn't cut it. And therefore, I decided that if I can help it next, I will not miss actual physical attendance. Although there were online questions and there was some interest, but I could not follow up on that. Although I know that generally there is much interest. Perhaps the other participants who were there can give better feedback about my presentation than I can.
Sounds good. Fair enough. Fair enough. Hopefully you'll get to engage in future sessions in person. I'll shift to Michael and Roloff. Maybe Roloff will start with you, and then Michael can provide his feedback afterwards.
So, of course, for us, it was a great opportunity to have direct contact with users of this LROS platform. So understanding what their main problems are and what their main wishes are is invaluable for us to prioritize what are the things that we need to work on. So during the workshop, we had quite a few interactive sessions where we asked their feedback on different components of LROS. So that on its own was really a valuable addition. But what was apparent in the conference is this wave of new young people working in the field. There's lots of new companies coming in, and AI was a really strong component of this. And it was great for Mike and I to meet some of the people working in the field, also listening to their ideas. And I think what we are envisaging with our project is sort of to put the framework in place that has been in place for a long time, where radar data can be used in an operational decision support system. But we also want to do it in such a way so that when people come with other models, we can fairly easily plug in those models into our infrastructure. And in that sense, making those connections and seeing what other people were doing was really valuable.
Excellent. Thank you. Mike?
Yeah, so, since this is the start of the project and what we gave was an overview, the main feedback we received from, say, the audience at the time was, this sounds great. It's really good that we got funded to do this work. And one thing I noticed at the conference was the number of sort of, interesting presentations that were funded by the UAE rep was very high. I was very impressed by that. And I think people, were excited that we would actually be able to devote some significant amount of effort to, improving the tools, the software tools that are available. We didn't have results to present, so, we didn't get any feedback on that. Obviously, what I enjoyed about the other presentations, specific, were the emphasis on trying to understand the physics, the microphysics, of seeding materials and of the storm environment and so forth, where I felt that it was, there was real progress being made on some of these topics which have really been sort of fuzzy and difficult to describe in the past. So I think the detailed work that's happening in the cloud chambers and in the modeling is very encouraging, because it will fold into our project, because we're also looking at, supposedly at microphysics, but of course at the radar level, it's somewhat more at the macro level, because we don't have, we have to look at aggregate properties. But I think the two things together will be very powerful going forward.
Yeah. Great. Will, your sort of perspective on feedback and insight from attending?
Yeah, it was a good conference. It was enjoyable, good venue. But what I felt that the interactions that we had with people there, because it was size-wise roughly right, we got to have a lot of conversations with people, in person, and I found that it's sort of I haven't been back in the WeatherMod arena for very long, and it really helped me sort of get a sense of what was going on and who the people are who are actively involved. So it was very helpful from that point of view.
Great. Thank you, Mike. Will, your insights and feedback on your presentations?
I did get a couple of people who told me that they really enjoyed the presentation and that it was good. So that's always nice to hear. I appreciate that. More in depth, though, I was really impressed with the level of technical detail that I was asked about. And the reason for that is because it really shows that people are engaging with the substantive points that you're trying to make. I mean, I was getting questions on, well, this particular thing could have been that or the other. Did you consider? And I really appreciate it. And, this was like 5 or 6 slides into the presentation. So it wasn't like people looked at the first 2 slides and then went to sleep. They were really engaged. And I really appreciated that. And I also appreciated the conference organizers' attempts to give everybody a voice and a chance to ask questions if they wanted to through the system that they provided.
Great. That's really good to hear. That's really good to hear. So my next question sort of continues to pull on this thread that I've set up, which is, for most of us working in this field, we kind of, I won't say it's too niche. It's niche enough, but because of that, everyone is sort of familiar with everyone else in the field, and so for me, what I'm curious to hear about is opportunities to engage in this manner in conferences and proceedings that bring folks that work on this topic. My question really on that is, what do you see in terms of the role of these types of engagement platforms, whether it's the Weather Modification Association meeting, the annual meeting, or in the case of UAE reps, biannual or every other year International Rain Enhancement Forum. These platforms have a role to play in our field, obviously, in helping sort of bringing the experts together, the practitioners together, and as you've all stated, sounds like effectively disseminating the work of said practitioners. But I've had conversations with other peers that are involved in organizing these types of platforms, and there's always a question of, and this is the question I'm posing here in a very maybe verbose way, which is, what are some of the ways these platforms could be improved or strengthened in order to enhance collaboration, enhance innovation, knowledge exchange, all these things that you expect and hope to get by attending and participating, using the WMA, your WMA experience as an example, your most recent one. And all of you have kind of answered part of this in your previous responses, but just to focus on it fully, what are some of the things based on your most recent experience at WMA? And you can feel the pull further back from other engagements that are similar. What could be done to sort of improve those sort of sessions and platforms in order to kind of help the field move forward? And in this case, I'll ask Mike to start first.
Yeah, difficult question, but there are two aspects. Danny mentioned, how if you're not there physically, it certainly, your participation feels somewhat limited. And so I think if in an ideal world you'd have everybody there in person, so that would be an obvious improvement, right? But of course, that's not something that you can really, control that much. What we did decide on the workshop side of things, we decided to make it in person only, so it wasn't hybrid. So we were working only with participants in the room, and that was great. We felt we really achieved a lot in that session, in those two. It was a one-day thing. And then we decided that the next time we do it, we would probably do it remote only. And so, and then it can be open to, people worldwide without having travel expenses and so forth. And so what I would say in terms of improving it is that if you alternate a sort of an in-person with a remote meeting or workshop or whatever, you can actually hold these more frequently without increasing the costs significantly. And the remote only ones, because remote stuff does work pretty well these days, it means we could interleave in person with remote meetings or workshops in an effective manner. So I think that is worth considering, and we'll definitely do that with our next workshop.
Great, excellent. Roloff, your perspective on these types of meetings, and obviously using the WMA as the recent example of how can they be improved to help the field?
So I think firstly we have to acknowledge the massive role that the UAE Rainfall Enhancement Program has played in the last decade or so. And it was undoubtedly felt at the conference. So not only were they a sponsor of the conference itself, but 1 in 5 talks were from people receiving funding in current phases. If we extend that to people that has received previous cycles, it's even more. So I think answering your question, what can be done to enhance the field and this international collaboration is undoubtedly funding for international research. The fact that the UAE REP involves people from all around the world makes it so much more possible for us to see what is going on and what has been going on in the last few years. So that would be the first very strong comment I want to make. secondly, what was amazing about this conference, and it's also true about the IRIF, is that so many different nations is involved. So, for example, we listened to talks from China, Thailand, Bulgaria, Russia, and much of that research don't always get translated into English. So we don't know what's going on in those countries. And a meeting like this gave us such a valuable insight into what's going on there. Firstly, but then secondly, making those connections so that you can actually pick up the phone or the email and having that personal connection to people. So I think meetings and forums like the WMA and IRIF are massively important, and it helps us to share methods, to have comparable evaluation standards, share data, and have open, honest communication about what is lacking and what are the main things that we have to work on. I loved Will's comments about receiving those comments about his presentations. And that is what's desperately needed, is we need to, in this forum, talk about what are the next steps that we can take to take the field forward.
That's really, really great to hear. Thank you for highlighting those particular points. I think that's what you want to see from these types of engagements. Danny, I'll pass it on to you. Just sort of your broad assessment of these types of platforms and how can we improve them to improve how the field works.
Okay, there are so many conferences on cloud physics, and perhaps most of the important contributions come not from people who are specifically focused on weather modification, because cloud physics is the essence of that in general. And that is the reason why I was spread too thin and missed this in-person opportunity. So the meetings are having difficult time to reach the critical mass of the attendance. And I think that what the field needs is a central meeting which everybody will feel compelled to attend. And the UAE is in a position to do so. There is every 4 years the WMO Weather Modification Conference, which serves these purposes, and I did attend it. It was absolutely great. But every 4 years for such a rapidly evolving field is just not enough. So my plea to the UAE is try to expand the bi-weekly meetings in the UAE to something that is available to most people, and encourage the attendance in person. That will be extremely valuable. The UAE is in a key location, geographical location, which is accessible to the whole world, although it's a bit far from America. But let's look at the center of gravity where the needs are.
Yeah, no, that's a great point. Not to draw on current, sort of upcoming things, but it becomes like the World Cup. It's only every 4 years in the case of the WMO. So there may be a sweet spot of frequency, right? Of often enough, but not too sparse. In contrast, Will, your thoughts on these types of convenings and how to improve?
I'll reinforce the previous comments and won't go back through that. The two things that I will particularly point to, I thought there were a couple of really valuable panel discussions at the WMA conference, and those kinds of discussions and airing of, maybe a little speculation, maybe a little bit of opinion, but also some direction, I think can be quite valuable. I also found it quite valuable to interact with younger scientists. So at the dinner that the conference hosted, I was seated beside somebody who had recently come into the weather modification space from cosmology. Very interesting shift. And getting those kinds of perspectives is, frankly, I think it's the way for senior scientists not to become old and out of touch.
Very important. I agree. I think we have a sort of a responsibility to, and this is going to dovetail into my next question, but how do we keep the field alive? And it's that passing of knowledge, right? And maybe not the full torch, but part of the torch. We could still hold part of it as we pass it along. We don't have to let go quite yet, but it is important to sort of pass that almost institutional knowledge that many of you have acquired throughout the years, and it's really hard to replace that without actively taking a role in transferring that type of information. My next question is again, taking this a little bit broader. We've talked about your particular projects. We've talked about the projects, aspects of the projects you shared at the meeting, the role of these types of meetings, and how we can keep them functioning and improve them. My next question is taking a broader sort of view here, pulling on what you have said just now for these other questions, based on your current work, based on your work with UAE Rep, based on the WMA meeting and other types of convenings. More broadly, as it relates to the science and field of cloud seeding and rain enhancement and weather modification, what is your assessment now that you've engaged with others at these types of convenings? What is your assessment of what's needed to take the field further and move it to its next step in terms of impact? And this could include answering this in terms of technical readiness, I can't even say this word properly without stumbling, operationalizing mainstream adoption, funding support. What is needed to, I guess, to sort of pull on your last response, Will, to keep the field alive, but I think more importantly, to make the field thrive and evolve into the next phase. And Danny, I'll pull on you to answer this one first.
Okay, my response will be a bit visionary, but I think that we need it now. Let's start with the acknowledgement that the biggest difficulty or hurdle that we have to overcome in weather modification is the natural variability of precipitation. We have to actually pick up the signal. And the best tool that we have to do that is numerical weather predictions. But at the same time that we put so much emphasis on how aerosols can change the precipitation amount, none of the operational numerical weather prediction have any aerosols actually incorporated in its prediction. This is an intolerable discrepancy. I say an internal discrepancy that we should overcome. Ideally, if we and I think that now we can actually start to change the situation with the big advancements in the computer power to actually include the missing physics of aerosols effects on clouds. With the power to run such models and to include AI that will bring the predictability to be accurate enough to actually isolate the effect of aerosols on precipitation. It will not only improve the precipitation, but because precipitation is latent heat release is a main driver of the propelling the circulation systems, it is essential for any improvement of weather prediction, and therefore it is a goal that is common to the weather modification community and the full weather community and beyond. And that is where the most emphasis should be. Now, predictability to the extent that we can isolate the aerosol effects can lead also to controllability. Then we could simulate different aerosol scenarios, different seeding scenarios, and then we could control the aerosols to our benefit. Not only for an enhancement, but for also for mitigation of severe storms as far as tropical cyclones. And I'm not saying it just as a visionary. Actually, I'm applying it in the framework of a startup in San Francisco named Elus, where we are developing this kind of model that will allow to do this kind of wonderful things in the future. So that's where I see that where we could unite force in circles that are much greater and powerful than the operational weather modification community.
Great, excellent. I feel that connects to, there's the most magic question, or $1 million, with inflation, it should be several $billion question, which is, we always get asked this question, and I hesitate to say this now because I don't want to influence others' response, but maybe it is you agree on this notion, is we always get asked this question, really, how much more rain or snow or precipitation does cloud seeding add, right? This is always the fundamental question, especially outside of our field, that the layman asks when we talk about our work. So I believe your response certainly, is trying to get us to eventually answer that question, hopefully. Will, I will ask you that same question as well and get your response on how do we move the field forward? How do we sort of evolve it to the next, hopefully, evolutionary step, if you will?
I have two pieces of evolution for you, and my first is this: pivot from does rain enhancement work? Because we know it does. It does work. So stop asking the question whether it works. Ask the question, how can we make it work better? And I will add a point that Danny just raised. Can we predict it better? And actually, not even can we, but move to the direction where we can predict it better, because we do have the ability to predict it. We just don't have the ability to predict it as well as we want. So that's the first thing. And the second thing is taking a step back even from that. The field is grappling still with a PR problem. So I think what needs to happen to move the field forward, don't overpromise, but don't be too modest. And I'll leave it at that.
That was very well said. And another sweet spot, if you will, in terms of not too much, but not too little. I agree. I think unfortunately, my perspective on the PR issue, it sort of ebbs and flows based on external factors like political climate, or just sort of the public's engagement or level of engagement with science. But that doesn't diminish the fact that it should always be there, regardless of if the public is favorable on their sort of influence of the field and so forth. Mike, I'll pose the same question to you on next steps for the field.
Thank you. But following on, Will talked about making it work better. I mean, I think that's obviously true, but another big problem we have in convective seeding is scaling the effort up. I mean, we've studied, we've done randomized experiments and studied, seeding on individual clouds and how they respond, I agree that I think we have shown that, there are effects there that are real. But then if you really want to make a difference to, say, aerial precipitation, in the case of convective seeding, you really have to seed more clouds than, a typical project is able to do. So that's a huge issue that we have. And working on how to scale it up, it probably means we need to go to some of the places where they have done that, in a reasonable way, like where Thailand flies, say, a lot of aircraft. So maybe we should visit there and see how do they handle that sheer number and how many clouds do they seed. I don't know how effective their seeding is, but they certainly put a lot of assets out there. So it's worth studying how that is done and how we can improve that.
Great. Roloff, your perspective on this question?
Yeah, those are tough acts to follow. I think most of the good ideas has been taken, but I want to add to Will's thoughts about asking the right questions. And I think we've seen this at the conference, that people are not, asking did rainfall increase, but we should rather ask what physical signal has changed, and under what conditions and with what certainty. And that shift is happening in the community, and that's really so that really focusing on the physics of the problem. And I think that links to Prof. Danny's answer as well. If we look at the current models around and we want to model what is happening when we attempt to change the aerosol loading, it is very difficult to find models that can accurately reflect our current understanding. And that brings me to another very good place we at the moment, is we're seeing all these different groups working on the problem. Not only the modeling groups, but also like Will Cantrell's group, focusing on really understanding the physical steps. And at the WMA, that was really interesting talks. One of his students, I think it was Corey, linking those observations to the one-dimensional model, asking questions like, what is the implications of just changing the place we seed, or the kind of seeding material? These are operational questions that have plagued us for decades, but we are seeing that we are at that place where we can start to play with these ideas. So that's really exciting about where we're at, and the fact that we have these projects that's ongoing. And then also the remote sensing work, looking at a larger scale, and that we're able to link all these scales together. So that would be my first major point, right? Moving towards understanding the physics. And I hope you see why Mike and my project, why we're working on this. We deeply feel that that's one of the important future questions to answer. But then secondly, and this has also been said, is making sure that we can deliver the right seeding material to the right cloud. What is clearly an old idea is the fact that not all clouds are seedable. But when we look at operational projects and even research projects, we see that people mostly go and take every opportunity they can get. But we're getting to a place where the technologies are there to put decision support tools together so that we can evaluate what is the current situation, and is this a good day for seeding? And so that when we choose these cases, that we are more certain that it is cases that will actually respond. And maybe we can get rid of some of this natural variability by doing a better job at choosing our seeding candidates. So those two dimensions is for me very important. And Mike mentioned the ties with all the aircraft, but I'm also excited about the prospects of UAVs. And I know that the UAE REP program had that in the sixth cycle. And I'm hoping that that people are still working on solutions to deliver the seeding material on scale, because that remains one of our biggest challenges, is delivering the seeding material at the right place and time.
Great. Those are great points to highlight as areas of improvement or moving towards. And I agree. I think much of that is almost aligned with incorporating technology as it improves moving forward with the more interesting questions we begin to ask or continue to ask as we advance the field. So I have one final question for all of you, a brief one. We started talking about your project, so we're going to go back to that, but I'm going to ask a very different question, not very, but slightly different question, which is, I know you all presented at some capacity at WMA, but I'd like us to have the latest scoop here, if you will. So in terms of your respective projects, what is the next step, or what are you working on that you're willing to share? I know the projects are ongoing, but what excites you currently about your project that you're working on now that you can almost plug, just as a sort of a point of excitement or even pride, just to sort of share that with our audience. And I'll flip the order again this way and have you start roll off on this question.
So that is an easy question for me, and I'll steal all Mike's ideas. But the thing about our project is the fact that it's built on open source software. And as we are getting these ideas, Mike is putting them on the code base, and people can basically download the latest and greatest there from the GitHub repository. So many of our promises has already been started in the code base, and people can see them there. And I think to put it in layman's terms, one of the things that we want to do with this project is Alrose has always been an open source project, but some of the components has remained a little bit of a barrier for entry. And one of them was the file formats. It used a fairly niche file format that made it difficult for new people to come into the ecosystem and to build on it or to tie their products on it. And that's one of the things that we are working on is changing that to one of the widest known and used formats. And I think Mike can talk a little bit more about it, but I think that work is almost done. So watch the GitHub space and you'll see all the latest and greatest.
Great, excellent. Mike?
Yeah, the thing that I'm actually very excited about, you could say, is over the past couple of months, I have managed to make real progress on, in the past, we've done, for example, hydrometeor type identification in the polar domain in the radar data, and I've now created this app which, just to back up, Titan works in the Cartesian space. So I've created an app that creates a starting point for all of the downstream analyses, and it incorporates an improved version of the particle identification algorithm, and which pulls in a model so that we have the model environment to guide the particle identification. We've got beam blockage now in there in a detailed manner so that the QPE stuff, the quantitative precip estimations are better. And then we've added in at that step also the convective stratiform partitioning. So what we're aiming for is a building block, the starting point that has high quality data in Cartesian space, and then Titan and the downstream processes will all be able to use that. And I'm very encouraged, as to how good the results look. So I'm keen to share that quite soon.
Great, looking forward to that. Danny?
Well, now, actually, I'll talk about an obstacle that we overcame. As you know, Will is testing now in his lab the salt powder that I've started already 15 years ago. And we tried to simulate it with the spectral beam microphysics model. And we realized that actually we don't get much of an effect. And we found that the model has fundamental limitations, allowing them to do a very large giant CCN. and we struggled for that to solve that for a large part of the time until now. But finally, we have the working version, and now we can start to simulate these effects, which are substantial. Now I understand why we don't see much in the literature simulations at full scale, only for parcel studies or highly parameterized for the effect of hygroscopic seeding on deep convective clouds. Being able to do so is opening the way to the rest of the way to complete the project and see the effect in the remaining of our project. It means calibrate the satellite channels to identify the seedable clouds with this technology.
Fantastic. That sounds great. Will, give you the last word here on this question.
We have an intensive set of experiments coming up in about a month and a half, when all of our collaborators will come here to Houghton to participate in a 1-month intensive focused set of experiments. And what we're going to be concentrating on in that time is hygroscopic seeding and mixed phase clouds. Normally people think about mixed phase clouds and they think glaciogenic seeding, but mixed phase means there's liquid water, and liquid water will respond to hygroscopic seeding, whether it's 10 degrees C or minus 10 degrees C. So I'm really excited about the kinds of avenues that we're opening up with that, and stay tuned. I'll let you know in about a month and a half.
Great. Well, I appreciate you all divulging a little bit more information than you may have at the WMA meeting, just to have the latest and greatest. This brings us, yes. Sorry, did anyone have a final comment? So I think this brings us to the end of our webinar. I really appreciate all of your attendance and participation for those that are online, and thank you to our panelists for sharing their perspective, their status of their work, their engagement at the WA meeting, and what are very important, I think, messages overall as it pertains to the field of cloud seeding, rainfall enhancement, and weather modification. For those of you online or watching after the fact, please feel free to comment on the video. Please feel free to follow UAE Rep, and that way you are plugged into the next webinar in this series. Thank you all so very much.